Hey there, welcome to Brainy Hub. Today we are going to learn about heaps and their implementation in Python. So let's get started. A heap is a special type of a binary tree which follows the heap criteria. There are mainly two types of heaps. The first one is a min-heap and the second one is a max-heap. So let's look at them. This is a max-heap. In the max-heap, for every parent node, the value is greater than its children. For example, in this heap, as you can see, the root node is 20 and both of the children of 20 are less than 20. So in a max heap, the root node is always the largest value and its children are always going to be less than that. Like that, if you look at the children of root 20, which are 15 and 10, as you can see, they both have children which are less than them. So that's the idea of a max heap. A min heap is just the inverse of that, meaning the root node is always going to be the smallest value and every single children is going to be greater than its parent. So as you can see here, the root node is 5 and 5 has two children, 10 and 15, and both of them are greater than 5. So that's the basic idea of a min heap. Now let's look at a max heap example. The first thing to note is that every single heap is a complete binary tree. Now what's a complete binary tree? A complete binary tree is a tree where every single node has exactly two children except for the last nodes which are at the bottom, also known as the leaf nodes. And one thing to note is that in complete binary trees, the nodes are always from left to right. For example, if you look at this heap, all of the nodes have exactly two children except for the last node which has one children and the children is the right children. Now this is not a complete binary tree. The last node doesn't have a left children, it just has a right children. For it to be able to have a right children, it should first have a left children, since in complete binary trees we have to go from left to right, meaning if the left is empty, then we cannot add a node to the right. And in complete binary trees, the last nodes can have 0, 1 or 2 children. So they are not just limited to having 2 children. Now let's see how we can build a heap from this array using the heapify process. Heapifying is a process of converting a binary tree into a heap. In a max heap, we start with the last non-leaf node, meaning the last node which has children, and then we compare it with its children. If it has any children that are larger than itself, then we are going to swap it with its largest children. For example, in this heap, the last non-leaf node is 8. If we select 8, 8 has two children. The first children is 9 and the second children is 2. So 8 has a child which is greater than itself, which is 9. So we are going to swap 8 with 9, and then we are going to repeat this process throughout the entire tree or array till we heapify it. Now the time complexity for heapifying is big O of n, and the time complexity for inserting a value or removing a value inside a heap is big O of log n. So it's quite efficient. Now let's look at this in code. So to work with heaps in Python, we have a Python library which is known as heapq. So just import that, and this library comes built in Python, so you don't have to download it separately. This library includes all of the functionalities that we need for heaps. For example, heapify, inserting, removing, and many more. So let's try it. So to create a heap, first we need this empty list, and then inside that we can use heapq to push values, and then we can just use heapq to perform operations on it. So the first operation that we are going to perform is inserting. So to do that, we are going to use heapq.heapPush. So what heap push does is it inserts the value inside the heap. So you have to give the name of the heap, which in this case is just heap, and then the value that we want to insert. For example, 20. Now you can insert multiple values. For example, let's insert 10 and 5 as well, like so. Now one thing to know is that in Python, we don't have max heap, we only have min heaps. But there's a way to create max heaps as well, which we are going to look at later on. But by default, the heap is a min heap, meaning when we insert each of these, it is going to automatically be sorted from the least to the greatest, like in a min heap. Now to print the smallest value, you can just use the heap and then 0, which is going to print the value at the first index, which is going to be the smallest value. And if you run that, As you can see, it's 5 and 5 is the smallest value. Now you can also pop from a heap, and the way you do that is by using heapq.heap_pop and then the name of the heap. So this is going to pop the root node of the heap, which depending on the heap type could either be the smallest value or the greatest value. In this case, since our heap is a min heap, it is going to give us the smallest value, which is 5. So it will remove 5 from the heap and we can store it in a variable. For example, let's say root node. And once we have stored it, we can print it out like so. And if we run the code, as you can see, the root node is 5. And you can also print the heap like so, and it is just going to be in the list format, as you can see right over here. And we have removed 5, that's why it's not present. So that is a min heap. Now to create a max heap in Python, what we can do is when we are inserting the values, we can insert them as negative numbers. So I'll explain what I mean by that. First, let's create a max heap, which is going to be an empty array again. And now we are going to push some values inside our max heap like so. And let's say we want 20, 10 and 5 again. Now if we do it like this, it is still going to function like a min heap, and it will have 5 first, then 10, then 20. But if we want it to act like a max heap, then we can store the negative form of these numbers. So negative 20, negative 10 and negative 5. So what that will do is it will store the smallest value, which in negative numbers, the value with the greater number is going to be smaller, meaning negative 20 is going to be at the start, negative 10 after that, then negative 5. And when we are popping from the heap or acquiring a value, we can just multiply that by negative 1, and that will give us the positive form. So that's how you can create a max heap. Now to perform these operations, what we can do is if we want the first element or the greatest element, we just add a negative sign in front of it, which will multiply it by negative 1, which will effectively convert it into a positive value. And you can also do the same thing by popping. So if we pop from our max heap and in here we just add a negative sign, it is going to pop from it. Now to print it, we will have to loop through the heap, and for each value we would have to multiply it by 1. So I will just create a list right over here, max heap pos vals, which is just max heap positive values. And for each node inside our max heap, what we are going to do is we are going to append the negative of that value inside our max heap pos vals. So dot append negative n, which inside our max heap all of the values are negative, and if we multiply it by negative again, it is going to convert it into positive. And we can just print this out like so. And as you can see, that worked as well. And you can perform this in one line as well by just doing something like this. So if we just print this, what this does is we are going to loop through all of the nodes, which in this case we are using x to represent them, inside our max heap, and we are storing the negative of that inside the list and just printing that out. So if you print this, as you can see, this works as well. That was a quick overview of heaps. If you found this video helpful, don't forget to like and subscribe for more content. I'll see you in the next lesson.